Hello class, we're starting our rational function unit. Remember that rational is a ratio, and this is a ratio of polynomial functions. I would start looking at the notes. The R, the A, and the Y are going to be easy ones and familiar. It's the T and the E that are going to be new, and we'll talk more about that through examples. Let's jump into an example. So here's our ratio of polynomials. So we have a linear on the top and a quadratic on the bottom. And for R, you need to find the roots. It's what makes the top 0. So when you set x minus 1 equal to 0, you would just add 1 over, and you'd get an answer of 1 comma 0 is your answer. So that's where your 1 root is. So it's going to be at 1, 0. Let's draw that one right there. Okay. Now, the A is what makes the bottom 0, so you're solving another polynomial on the bottom. So it's just like last unit again, just like R, and we need to set the bottom equal to 0. When we set x squared minus 4 equal to 0, when you solve this one, you add the 4 over and you square root, and the fundamental theorem of algebra gives us plus 2 and negative 2. And so that means this is going to be our vertical asymptotes. Let's do that in red. So we're going to have one at positive 2, zoop, and one at negatory 2. All right, now T. T is going to stand for tangent in the top, and that's where it bounces off the x-axis if you have a double answer. This one only has one answer at positive 1, so this one's not going to be a tangent one. There's a chance for the bottom one, but it is two different answers. It's positive 2 and negative 2. But if they were the same answer, they would come together at the asymptote. So that would be called togetherness. So in the top, it's tangency. In the bottom, it's togetherness. This one is none, which is good. We can just write none. None. All right. E stands for end behavior. Sometimes we'll call them horizontal asymptotes, and I'm putting them in air quotes. And you'll see through some examples why. Now for E, the end behavior, you are comparing the degree of your polynomial. So in the top polynomial, the degree is 1, and in the bottom, the degree is 2. So it's bigger on bottom. Bigger on bottom. We call it Bobbio. Bigger on bottom. And we say that y equals 0. So y equals 0. And we're going to do that with it doesn't matter what color I pick, but I'm going to pick yellow. And there's going to be a horizontal asymptote or an end behavior at y equals 0. And you can see in this specific example that, that I don't like to call it an horizontal asymptote because there was a point right here on the end behavior. So it can cross your horizontal asymptote or end behavior. So because that's where our root is at positive 1. So that one needs to be there. All right, so the final one is the y-intercept, and you let x equal 0. If you let all your x's equal 0, you would get a negative 1 on the top and a negative 4 on the bottom. So negative 1 divided by negative 4 is positive 1/4. All right, and that's going to tell us where the y-intercept is, so positive 1/4, about right there, okay? Now, when you get good at these, you could just start graphing. I know that's going to look like this, and that, and this. But until we get there, let's talk about how we do this. So my question is, does it look like this, or does it look like this? And I'm going to test a point. I just need to pick a point left of negative 2. So negative 3. It really doesn't matter, but I'm going to pick f of negative 3. I could have picked negative 4, etc. When I do that, I get negative 3 minus 1, which is negative 4. And the bottom, I get negative 3 squared, which is positive 9, minus 4 is positive 5. When I divide that out, I get a negative number, just under 0.1, so it's going to be at negative 3. It's going to be right here. So it's on the bottom, which is more important. And I'm just going to make it at negative 1, even though it's below it. And it's going to look like this. All right, I'm going to make that a little thicker. Is that how you do it? Yeah, there. Oh, yeah, there you go. So it's a decent drawing. And if there was togetherness on this asymptote, so let's just say it was the same answer of negative 2 and negative 2 twice, they would come together. But unfortunately, there is no togetherness or whatever, so they're going to be opposites. So this one starts at this one's going to be at the bottom, this one's going to be at the top. Now, it normally goes to the next end behavior, but I have a root from the positive 1. So that's going to start up here, and then it's going to go through the root, through the x-axis, through the end behavior, or horizontal asymptote, and it's going to go down, go on forever. And then what we're going to do is there is no togetherness again, so it's going to start up at the top, and then it goes towards the end behavior. So the rule is it kind of always goes towards the end behaviors. And this did exactly what I thought it would. When I was talking about it earlier, I knew that it was gonna, since I had the 2 points, I had the winders. By the way, it should have gone through here. I should have drawn like that. That's actually a little better. Whoops, whoopsie. So, but I said it was going to go up here and then down here, and then they're always opposite. So they go towards this end behavior, or this asymptote, and then towards this asymptote, root, asymptote, and then asymptote. All right. That's pretty much it then. And then again, some of the questions that you'll be asked about this later is what are the answers and or the solutions, and that's going to be your roots, just like we did for polynomials. All right. Whoosh, let's do it.